And welcome everybody to the Daily Space Weather video. Today, lots of stuff to talk about. I'm your host, Dan, aka smAsho, and we'll be talking about new beta class sunspots. That's 2809, active region 2809, volcanic and physics hotspots, and how Lightningmaps has burned. Lightningmaps burned, yes. Seriously, I'm not kidding. Lightningmaps.org has burned. We'll get to it much later in the video in the meteorology segment. So here's the closest star to your likely location. Leave us a comment if you're viewing from a different solar system, galaxy, universe, timeline, or plane of existence. Here's the sun in colorized magnetogram. So the main sunspot is this one up here. This is 2808. And we've also got a new group right here, a beta class pair of sunspots, at least two umbrae there. Sunspot 2809. That'll get named today. Here's the intensitygram. That was a colorized magnetogram. And we'll zoom in a little bit so you get a little better view of that. There's 2808. And here's 2809. It's an active region that kind of reformed. So here's the latest frame on the SDO browse data. There you go. I see two umbrae. What about you? Let's get our viewers oriented. And hey, Evan, did you look up the etymology of the word orient? I didn't, but in any case, here's where stuff is located in the solar system. And there's where things will be oriented in 1 week. Here's a star chart. I like to draw in the ecliptic and face mine to the south, but you can face yours whatever direction you like. Just put in your location. You can build your own star chart at in-the-sky.org. If you're up before dawn and you've got clear skies, you may see Saturn and Jupiter rising ahead of the moon. I mean, ahead of the sun, rather. Yeah. They look almost the same size in the sky, by the way. So yeah, you may see Jupiter and Saturn rising ahead of the sun if you're up before dawn and you've got clear skies. Let's get back to solar data. The radio flux has dropped back down to 79. So here's a Solon.info's graph on this, and I'm reporting the number of 79 here before it's reported. Although it is there on the graph. It did go up to 84. And we can expect this to increase in the coming days as there's some activity rising in the east. Probably a large sunspot, actually. But in any case, there's the radio flux through cycle 24 and into cycle 25, as well as sunspot number. You can see how proportional the 10.7, known as the F107 to some people. And let's talk about volcanoes. Now what we're looking at here is the 3 kilometer by 5 kilometer magma chamber underneath Fagradosfjall. Fagradosfjall? Fagradosfjall, yes. There we go. I've said it, I think. Lots of volcanoes erupting. It's a major volcanic uptick, really. I mean, Mount Etna has been going off. It's had about, 13 different paroxysms, lava fountaining explosive events, dropping pumice on neighboring towns and so on, and creating ash plumes that are quite significant, some up to 30,000 feet in altitude. So Etna, but Fagradosfjall, there we go. Fagradosfjall has been looking like it may be setting up to erupt in an epic fashion. And there's a giant magma reservoir 7 kilometers long underneath this volcanic caldera. So obviously there is magma migrating upwards, according to Freystein Sigmundsen, who was interviewed on March 9th. The growing magma reservoir was shown to be in the form of a dike. It's currently about 1 meter wide and 7 kilometers long, spanning the length between Kailir and the northern end and Fagradalsfjall at the southern end. The bottom of the magma chamber is located 5 kilometers below ground and the site for the magmatic flux. This is the process by which magma flows from deeper sources in the mantle toward the shallow magma chamber where it is now being stored. So there's basically some sort of a hell on earth situation going on just below the ground there in Iceland, as magmatic earthquakes continue under Fagradalsfjall. Sakurajima is also erupting, 6,000-foot ash plume there at Japan. Suwanosejima also exploded, 5,000-foot ash plume there, 5,000-foot ash plume at Kadavar, northeast of New Guinea. Pyroclastic flow happened at Cinnabung after Volcanian-style explosions, creating a dense ash column to about 3,300 feet of altitude. Semeru also erupting. The East Javan Indonesian volcano of Semeru exploding. 14,000-foot ash plume there. 8,000-foot ash plume as Dakono explodes. Mauna Loa saw a 4.2 magnitude quake at 16 kilometers below the southeast flank yesterday. And we've reported many volcanoes. One volcanic earthquake was at something like 10,000 feet of altitude, directly below the Mauna Loa main caldera. It has been seen expanding for years, and Mauna Loa, I would remind you, is the largest volcano on Earth. Popocatépetl also exploding. Flight level 190. It's a 19,000-foot ash plume there. Pacaya exploding. 12,000-foot ash plume there after another lava fountaining episode, likely to be classified as paroxysm. So major volcanic uptick here around the world over an extended period of time. Sangay volcanic ash clouds dissipated in satellite imagery down in Ecuador, and volcanic ash not seen in satellite imagery at Revenador, an indication it could be erupting. Sabancaya is exploding as well in Peru. It's producing a 25,000-foot ash plume. Please do not attempt to hang glide, fly your ultralight aircraft, square dance around the caldera, or pole vault over it. Don't pole vault the caldera, folks. It's not the way to spend your day. Pole vault in the proper environments only, not over volcanic calderae. So that's some wisdom, and I know we have to inform people of this because it's 2020 and people have become deranged. So please press like and subscribe so you can hear more important safety tips like that here at the Smash News Network. Let's get to earthquakes, as we see about 50 trillion aftershocks here north of New Zealand. I'm exaggerating for emphasis. Here's a deep quake in the Caribbean. Leave us a comment if you felt that, Peter Schiff. I don't think so. That was not at Puerto Rico. It was at Dominica. There's a deep quake near Timor-Leste. A deep quake at the Fiji Islands. And a 5.8 magnitude at Tonga at nearly 500 kilometers depth there. Another deep quake at Tonga. That one of lower magnitude. So a 5.8 and a 5.0 at 488 and 552 kilometers depth, folks. 4.3 at Afghanistan at depth. I think that 5.8 must have been the largest of the past 24. Here's a 5.1 at the Kermadec Islands as the aftershocks continue there. Here's a deep quake at Argentina. So simultaneous deep quake and volcanic correlations going on here in the past 24 hours. The Aleutian Islands saw a deep quake. Let's get back to some solar data. No solar flares over the past 24 hours. We did document this C-class flare in yesterday's daily space weather video. There's the proton flux. Over the past 3 days, no proton strikes, and no surprise there. We would have let you know ahead of time, most likely, if this was about to spike. Next is the GOES magnetometer. And it's fairly smooth here over the past 3 days. It's about to get a little choppy on the GOES magnetometer, as there is some coronal hole wind on the way, as well as some, let's just say, changes in the chromosphere about to rise in the east. And you can see evidence of that. Some newly formed regions, actually, are going to show up in the southern hemisphere. You'll see them when they rise, but, and by the way, I'm getting this information not by looking at it on the stereo A imagery. I'm getting it by looking at this imagery, the top view ecliptic plane field plot. This is part of the National Sunspot Observatory, and you're looking at the magnetic polarity of the heliospheric current sheet. The heliospheric current sheet, yes. In any case, we do see a slight increase in the probability of coronal mass ejections, as well as solar flares, as we have a beta-class sunspot in the Earth-facing portion of the solar disk, and we see an active region rising right here, and that will be south of the equator, right there. You see that little change in the polarity there? That is likely a sunspot, possibly a large one, and certainly south of the equator. So in any case, here is the line of sight coronal hole plot, and you can see this relatively small coronal hole system here associated with the South Pole. That one is just moving into the direct Earth-facing zone right now. And we can expect a coronal hole wind stream from that in about 3 days, would be the best guess. And this image also shows the sun's B field in blue. Next, we'll look at the real-time solar wind, kind of an important piece of data here. And we see a significant drop-off here in the density. Solar wind density now less than 3 protons per cubic centimeter at 2.62. Solar wind speed 374 kilometers a second. Phi angle currently pegged at about 58 degrees for the past 7 hours. And no major changes in the BTBZ. Again, the Earth is solidly in a South Pole-oriented current sheet, where we expect to remain for the foreseeable future. Next, the KP index, a measurement of global geomagnetism, is at 1, having come off of its lows here. It's spent 21 hours, nearly a full day at a KP of 0. Did you know that cosmic rays don't always correlate with KP 0 days? Well, that's part of the reason why we show cosmic ray data on the channel. We won't today. But here's a visualization of the magnetosphere. And we're looking at actually density as well as pressure today, because we should see the density drop off. And those light colors coming in from the left, that's the solar wind dropping in density. So low density shown in white here, high density shown in dark blue. And you can see that sort of magnetic sheath around the planet. Here's the pressure. Now you're looking at nanopascals. We were previously looking at simply protons per cubic centimeter. The density, now the pressure. So these are both 4 hours of data. And you see a low pressure, which is going to drop to an even lower pressure. No real surprise there with that very diffuse and pretty slow incoming solar wind. So we don't see a lot of ground magnetic perturbations induced by those incoming solar protons. Here are the polar views of the last 4 hours. And you'll see geomagnetism drop off here once again. We'll probably go back to a KP0 here as we're seeing, very low levels of protonic input. Very low levels of Bremsstrahlung, breaking radiation caused by those protons. So here is the global view. And we show this daily due to the polar excursion. Were you aware that the South Pole is actually down here someplace? And while the net North Pole is here, we've got two. One over Siberia and one over Canada. Well, we're glad you could catch up by watching the video. By the way, this one was not streamed live to Twitch. And just a quick note about gaming. I do gaming. If you want to find me on TrackBase, it's et.trackbase.net. You can do a search for $$F #smAsho', and you'll find me there. I actually played yesterday. Not bad on Castle CTF, not one of my stellar maps, but I came in 5th. And we saw some of the best players in the world, including Feint from Serbia, who was actually 10th in the world while we played that map. Come check us out if you like. Also, don't forget to press like and subscribe if you're viewing the videos on YouTube. We also do feature our content on BitChute. Did you see our video yesterday about safety and the Nissan Cube, one of the silliest vehicles I've seen? It was good times. But seriously though, if you're watching on YouTube, don't forget to press like and subscribe, as we need your assistance to get the content out there. The algorithms are trying to kill us. I'm just kidding, folks. The algorithms aren't really trying to kill us. Don't worry, it's not the COVID. Let's do a cosmology segment. By the way, smAsho.org is involved in cosmology. We're not only looking for sponsorship, but also grants. And we've started approaching the National Science Foundation already, but in any case, we need your assistance. So visit our links and so on. smAsho.org. smAsho.com is where you'll be redirected. One of the things you can find there is our forum. And one of the things you can find on our forum is our mission. Now, there's no link. You have to actually go up here and type the word mission. And if you do so, you'll find this page, smAsho.com/forum/mission, where it talks about our mission. And I'm just going to let it scroll and not read it. If you need to pause the video, feel free. Our mission will still be there for you to read also at smAsho.com/forum/mission. Cosmology figures in. And today we're going to pick a random number, which is 874, at the Neil Gorell's Swift Bat X-ray Observatory, the Burst Alert Telescope. And what's 874, you ask? Well, 874 turns out to be SGR 1900 plus 14, which is an SGR. I have no idea what that is. But in any case, it's an X-ray source. So there are the X-ray outputs. Let's see if we can get an image of it on Simbad. And I don't see anything there. Let's check Aladdin Light. How about an infrared? One of my favorites, the 2MASS. And it's just a dark part of space in a very bright part of space, apparently. A large star there, perhaps in the foreground. I have no idea. But there it is on the 2MASS. A heap and helping of nothing. How about on the blue light spectrum? Nothing. How about XMM Multi-Mirror Project? Just that large star. And what about on Chandra? A heap and helping of zilch. Nada. It's SGR 1900 plus 14, the X-ray source. I'll have to actually look that up to find out what that is at a later time. That's pretty funny. Something obviously in the constellation of Sagittarius, I would think. I mean, I'm stumped on that one. Here's some links for you, by the way. How about Open Physics Lab? openphysicslab.org. They've got an entire link about cosmic rays. Look, they've just published an article on February 11th. Introduction in our experimental physics website. Cosmic rays. Cosmic rays are an unmissable appointment. This physical phenomenon always offers new possibilities for experimentation and always gives many satisfactions. Over time, we've used different experimental detection techniques. Geiger tubes, scintillation detectors, coupled to both PMT and SIPM. Cherenkov detectors, and I have no idea what PMT or SIPM are. I'll read that later. Also, I would invite you to check out Alexander Unziker, who cites some important facts, like the fact that there are all kinds of bits of unsettled science when it comes to physics. And we've actually reached out to Herr Unziker because I've got a weird question for him about things like time dilation, special relativity, whatever you want to call it. And so perhaps we'll feature Unziker on the channel soon. He's also got his own channel on YouTube, Unziker's Real Physics. What do you know about exploding stars? Now, in our cosmology segment, we talk about all kinds of different things. Well, what about the supernoval remnant discovered right near the galactic core of the Milky Way galaxy? Yes, were you aware of that? Well, let me just blow your mind by showing you this article, which you can find on space.com, by the way, which is essentially NASA's site. And there's a Type 1AX supernova remnant right near the core of the galaxy. So here it is on the Chandra. I believe this is actually a composite image. But in any case, there it is in X-ray. And what's interesting about supernoval remnants, folks, is that they seem to come in different flavors. So they're sort of classified by their chemical components, the chemical structure that is left behind by the supernoval explosions are the means by which astronomy categorizes them. Different types of supernovae seem to produce different light spectra and indeed different chemicals. And we're able to figure this out by using emission and absorption spectra. While observing the area, it gives us an idea of what chemicals that supernoval explosion has left behind. And is it even an explosion, or is it just an outflow? It's probably an explosion. But in any case, we're not exactly sure how they work. One of the theories is that white dwarf stars get too close together, and they blast off outer shells and so on. But there are all kinds of theory as to how it really works. We haven't really ever had a good view of what really goes on. But in any case, something's leaving behind interesting chemical components, and some of the information could indeed blow your mind. And we're hoping it does. Again, you can find this article at space.com. And thanks to our spaced out viewers, that's today's cosmology segment. And again, don't forget to press like and subscribe if you're viewing on YouTube. Share with your friends, your foes, your science noobs, and your science pros. We probably have something for all of them here at the Smash News Network. Let's get back to space. Here's what's going on in the electron flux over the past year. As we keep records of the density of the electrons out there in the Van Allen belts. Really, this is the ionosphere, as the GOES 16 makes its measurements at about 300 kilometers of altitude. So there's the 3-day chart of the GOES 16. And we're just about to go back into warning territory here. You can see that red dotted line coincides with 1,000 pulse flux units. This one is actually showing you particle density. It's a slightly different thing. I won't get into it. It's the daily space weather. So here's the relativistic forecast model, and you can see an expected dip here. And I would agree with it, at least. I would tend to agree with that, as there is a weak coronal hole wind stream expected to show up in about 3 days. I don't know if NOAA's forecasting it, but I'm forecasting it, so there you go. Here's the visualization of the electron content. showing you the electron density over between you and your GPS satellite, for example. And it's looking fairly normal there, nothing to write home about. Here's just a diagram of the atmosphere. It shows you the F ionosphere layer. We show that daily to help orient our viewers to what they're looking at. And here we're looking at about that altitude, around 300 kilometers of altitude here, the F ionosphere layer. It's a visualization of that in vibrational frequency. And by the way, for all you Schumann resonance people out there, were you aware that the Schumann resonances are listed in Tomsk time? Yes, Tomsk time. I have no idea what that is. It's like plus 8 hours universal time or something like that. Tomsk time. Did you know that? Anyway, this isn't the Schumann resonance. This is the ionosphere layer. And we do see some rapid charge ups here over the Indian Ocean. You can see it making up to 14 megahertz there. But in any case, here's the latest image. That's 10:30 universal time. And you can see indeed there we see a 14 megahertz portion off of the east coast of Central Africa. I would note this. We see some 96 mile per hour winds at least as this system in the southern Indian Ocean has kicked up. Check it out. It's quite a strong clockwise rotation here. Now this is the surface winds, and we can see reaching up to nearly 100 miles an hour there. Not a lot of folks around there, as that is quite a desolate location, thousands of miles from Madagascar. Here is the jet stream, and you can see a much weaker rotation there in the jet stream. I would not anticipate this lasting too long. It'll probably break up, and I have no idea what the storm track will be. It's in a very stagnant area of the ocean there. As you can see, the jet stream barely has any input. But we do see an input here, a signal in the 250 hectopascal winds out of that system. And it's rotating the same direction as the surface winds, an indication it might weaken. I would say it would weaken if I had to guess, which I don't. But in any case, here are the jet streams of the eastern world that we show daily. Here are the jet streams of the western world. And those are, I don't know, a little more normal than they have looked. Still quite chaotic here, especially this area right here in northern Africa, where we do see the jet stream blowing straight up backwards over places like, I guess, Libya. Backward jet stream there. Next, looking at pressure cells. And here are pressure maps on windy.com. Let me make sure I'm zoomed out. There we go. Very powerful low pressure system there. It's kind of a double in the North Atlantic and then into the, I guess that's the North Sea there. Arctic Ocean? I don't know what the heck it is. Arctic Ocean, I guess. Anyway, that's where pressure cells are now. Here's where we expect them to be at 12 noon Eastern time tomorrow, according to the GFS forecast. Here's the Euro forecast. And there's the GFS. And how about the icon? There's the icon forecast. And there's the Euro, and there's the GFS. Now, we talked about lightningmaps.org burn. Well, I wasn't kidding. The Strasbourg data center, a giant server farm in Strasbourg, burned in pretty epic fashion. Look at that. That is no good. That is uncool. But in any case, blitzortung.org is still up. Lightningmaps.org says they're experiencing technical difficulties as their server burned. So, we've been using blitzortung.org. And this does not have the same kind of zoom capabilities. It's completely different, sort of a different format here. And it looks like somebody's playing Missile Command. So, but in any case, that's a real-time lightning map, and we see some activity there. both in North America and Australia. Here's a cloud map. Looking at the lower 48, here's a water vapor equivalent. Clouds, water vapor, and back to clouds, and back to water vapor. Here's a US Doppler radar. Some more snow falling in places like Minnesota and Utah and Colorado and Arizona and Nevada. Some in South Dakota, and a string of storms here across Missouri and Illinois, about to move into Indiana, Ohio, and western Pennsylvania. Thanks to our patrons, the true source of funding for the content. Please consider funding us at patreon.com/smAsho. If you want the earliest alerts about things, well, our patrons get them before anybody else, as well as all kinds of other sweet graphics and things like wallpapers and even some free music from time to time. Patreon.com/smAsho. Also, thanks to Smash staff. And here come bonus features. So don't go nowhere, you hear? Don't go nowhere. You go anywhere, there's going to be problems, see? Problems. We got a colorized magnetogram and a solar intensitygram to show you the current state of affairs when it comes to the local yellow dwarf. Here's Sunspot 2808, which looks pretty similar to how it did last time we looked at it. It's degraded a little bit. And here's Sunspot 2809. It's looking pretty weak and small, barely even an umbra. It's not even dark in color, and it could be degrading. Here's a colorized magnetogram. So there's 2809, which is still a sunspot. I think it's going to get named. It's been there for quite a while. And there's 2808. And to prevent giving anybody seizures, I'm going to bring up the test pattern for a quick moment here and refresh my additional views of the sun so it doesn't look crappy. And we're sticking with the live format here, even though we're not actually streaming live. So here's a composite image. This is actually 3 wavelengths. It's 335, 193, and 94 angstroms. Another active region has formed, not there, up here. That has not shown any umbra yet throughout its short-lived time on the Earth-facing disk. Here's another composite. This is different wavelengths. This is 211, 304, and 171. They're all in different colors. 171 is actually in blue on this. SDO Browse Data composite. And here's one more composite. This is 171 angstroms and colorized magnetogram. And we'll actually zoom in on this southern area. To close things out. And thanks everybody for tuning in. We are out. Remember to stare at the sun, and when you do, don't drink. And if you do drink, don't drive. Do press like and subscribe. And since it'll never be now again, may that solar wind be at your back.